Hey everybody, this is Alex Merced, and welcome to this Dremio broadcast of Gnarly Data Waves. And today we're going to be talking about the Dremio's commitment to building open platforms on open source. And what does that matter? Like, why does open matter? For several different reasons. Because of flexibility. At the end of the day, when you have open platforms, it means these platforms work better with other tools, allowing you to piece together what you need when you need it, versus being sort of locked into sort of a very limited world of possible workflows and patterns that limit you when you need it. Speed, okay? If you're not having to use sort of completely different sets of workflows for different with different tools for every different and having to move your data across different tools because you're not using open processes, well, that takes a lot of time. I mean, imagine you have three different departments that are using three different data warehouses. You're trying to do sort of a company-wide like customer 360, and you're e-tailing all this data between these departments, the cost, the time that is lost, and all that. But on top of that, when you're operating in an open environment and using open tools that operate within open ecosystems, you get a lot of innovation. When you take a look at a lot of the technologies we talk about today, as far as Apache Arrow, Apache Iceberg, Apache Polaris, you have many companies who are building on these open primitives. And because of that, you're seeing a lot of innovation that basically enhances all this flexibility, speed, and cost. And Dremio has always been on the forefront of building a platform on top of these open primitives. Okay, Dremio was basically one of the first companies to embrace Apache Arrow. One of the co-creators of Dremio is one of the co-creators of Apache Arrow. Dremio was probably the first commercial vendor to really embrace Apache Iceberg into their product, and has really built a first-class Iceberg platform. And Dremio has was got to be one of the co-creators of Apache Polaris along with Snowflake. And has really again also built a first class Polaris experience into the Dremio product. At the end of the day, Dremio basically is always sort of early in identifying what these open primitives, these open standards are going to be, and builds around them. So that way you do have that maximum flexibility, speed, cost, and innovation. This is why Dremio cares so much about building on these types of primitives, so that way you have this type of result, this type of innovation with Dremio's intelligent lakehouse platform, where basically you can think about, I would like to think about the open part of Dremio's platform in sort of three different ways. You can connect your data from everywhere. So Dremio is open to your data anywhere. Not only can it connect to your Iceberg lakehouse, but it can connect to your data lakes, your databases, your data warehouses, so that way you can work with all your data in one place. It allows that data to be accessible anywhere. Okay, whether we're talking about people bringing their own compute through Dremio's built-in Iceberg catalog, people can bring their own compute, connect to the catalog, and run their own operations on those Iceberg tables. But using Dremio's REST interface, Apache Arrow Flight interface, and JDBC, ODBC interfaces, you can connect Dremio and its integrated semantic layer to your favorite BI tools, AI notebooks. There's an MCP interface, so that way you can actually just interact with Dremio using a natural language. However you need to interact with your data, Dremio allows all your data to be open to all your workflows, okay, being the sort of nice unified platform for executing a lakehouse and getting the kind of performance and lower cost and flexibility that you need. Because again, Dremio builds on these open primitives such as Apache Arrow, which started off as an in-memory format. It starts off as a way of representing data in memory. So that way there's a standard columnar way to represent the data in memory. Now the project, after coming up with a spec for this standard, includes libraries that allow you in any language, whether it's Python, Rust, Go, C, C++, to be able to work with Apache Arrow when you're building your tools, allowing many more tools to actually be able to incorporate Apache Arrow. Again, co-created between, Dremio and Wes McKinney. Basically, it's seen rapid popularity and growth since. It's pretty much now become an industry standard, and the way you build your engines if you want performance. Okay, if you're not using Apache Arrow, you're leaving performance on the table. But the Apache Arrow project didn't just address how to represent data in memory, because at the end of the day, there's still the bottleneck of transporting that data between systems over the wire. And that's where it came up with Apache Arrow Flight, which was this gRPC framework or protocol for sending Arrow data across networks. So that way, instead of having to use JDBC, ODBC, where you would have to serialize it into row-based data and then continue to reserialize it back into columnar-based data, you can just keep columnar throughout the entire process. This also enables, parallelizing the processing of this data, overall basically enabling another layer of additional performance. And you can see here, accessing the same Arrow-based data using JDBC versus Fly, you can see that there's some really significant differences in performance, especially when you start getting into larger and larger numbers of records. Now, ArrowFlight SQL was an interface to ArrowFlight, allowing you to send SQL to ArrowFlight for basically processing your SQL queries. Okay, so that way, instead of sending sort of like very specific requests, you can write SQL, but then a SQL engine will then process and execute using Arrow. But at the end of the day, not all columnar systems, not all columnar stores use Apache Arrow as a way they represent data. So in that, a couple really cool things kind of came into mix. One, Dremio created an ODBC JDBC driver, so that way you can take advantage of ArrowFlight when using ODBC JDBC. But on top of it, a whole new protocol called ADBC, Arrow database connectivity, came into existence, allowing other columnar systems to use a standard protocol for transporting data in a columnar way. So basically, you have your Arrow flight drivers for connecting to Arrow flight supporting systems like Dremio and InfluxDB. But then you can have other drivers for other systems that do have their own columnar representations, but need a way to transport those columnar representations. So overall, you get this really big ecosystem within the ArrowFlight project regarding, again, how to represent the data in memory for faster processing, but then also how to transport that data over the network for faster performance. And then it doesn't even end there. Okay, when we take a look at the Arrow ecosystem, of course, Dremio was built top to bottom using Apache Arrow, but then there's also Data Fusion, an open source query engine that's become sort of this primitive that a lot of different products are building into their products, whether they're semantic layer companies or other types of companies that are just building, a layer with Data Fusion, and this sort of just off the shelf Apache Arrow engine that you can just kind of grab and throw into things. There's Gluten, Velox. There's also another thing called Apache Comet, which came out of Data Fusion. And these three projects, what they're doing is they're trying to give you a interface to be able to replace the guts of Spark and replace it with, not the native Spark query engine, but with an Apache Arrow-based version for much higher performance on your Spark workloads. So Apache Arrow is everywhere and anywhere. And basically, either engines have already built a way to work with Apache Arrow, whether they've natively built it top to bottom like Dremio, or they're incorporating Data Fusion into their product, or building some sort of swappable interface to swap out their existing sort of processing with Arrow. These projects are either there or they're in flight. Again, becoming an industry standard. But who was there early on and who was there first? Dremio. Okay, Dremio is always committed to kind of sort of building on open standards and identifying those open standards. But it's not the only standard that matters. Another standard that's become quite ubiquitous is Apache Iceberg as sort of the industry default for what table format should you store your data lakehouse data in. Okay, when I talk about it with data lakehouse, what does that mean? Well, traditionally we've used databases and data warehouses that would abstract the way the data was stored, how we recognize tables, how we cataloged those tables, and how we would parse and execute queries. Databases would handle all the transactional row-based workloads. Data warehouses would handle all the columnar analytical-based workloads, but the problem was every system had to have its own copy of the data. So again, when you start getting into larger enterprises, we have multiple departments working with different databases and different data warehouses. This results in lots of copies of the data when you start trying to do more cross-dimensional or cross-departmental analytics. And that just wasn't sustainable, wasn't cost-efficient, it wasn't fast enough. So there had to be a better way. One approach was to say, hey, instead of doing the analytics right in the data warehouse or database, how about we export a bunch of that data as files, like Parquet files or C files, CSV files, JSON files. And there's also unstructured data like images, videos, and text files. But the idea is to put the data in a storage layer, and we'll call this layer the data lake, and we can just run analytics directly on that. And that works. So you have a data lake where you can have data stored in an open storage layer, like a Hadoop, an S3, an ADLS, and run analytics against it using tools like Dremio and AWS Athena. But it wasn't quite as easy as working with the data warehouse, nor sometimes wasn't quite as fast, or had some of the niceties like schema evolution, etc. Because what was missing? A lot of the other things that are going inside of a data warehouse, a database. So if we were to inject those two missing layers back, the table format, a way to recognize these groups of files as tables and understand them in a more granular, deeper way, and add in a catalog that can track these tables and govern these tables, well, then we kind of really do have an interface that's very much like interacting with a data lake, a data warehouse. Thus, a data warehouse made out of your data lake, a data lake house. So the ending result of a data lake house should be that you have your data sources, you ingest them into your data lake house. Okay, data files, generally Parquet files, table format like an Apache Iceberg, a catalog like an Apache Polaris. And now all your tools can talk to that lakehouse and run operations on that data without having to copy the data between systems, which so allows every department to use their preferred tools with the same data. But when we think about a table format at the end of the day first starts with the actual data files, which are Parquet files, which were designed to be able to, the innovation of Parquet files was to break up the data in the Parquet file into separate row groups that are structured columnarily. It's stored in a binary format, which is all great for making the files smaller, which is great for transporting them over the wire. But by storing the data into different row groups and providing each of those row groups with a footer of metadata, we're able to then take a look at that metadata and say, hey, this row group I need a scan, this row group I don't need the scan, allowing you to do what's called predicate pushdown and skip parts of the file, allowing you to scan that file faster. And that's wonderful. But what happens over time is that your data sets get bigger and bigger and bigger, and eventually they take up more than one Parquet file. Okay, and the problem is these Parquet files, they have metadata of what's inside the file, but they don't have metadata for the other files outside. They don't have external metadata. And this is where a table format comes into play. The idea is like, okay, how do we recognize this group of files as a table? The original approach with Hive in the early days of data lakes was just to treat a folder as a table. So a folder of files, anything in the folder is a table. And while that works, it wasn't efficient. It resulted in a lot of file listing operations. Granular updates were really inefficient, very limited ability to evolve a table and do transactions very safely in only very specific sort of situations where you're like swapping out partitions and things like that. It wasn't great. So the solution to that was to have much more granular definitions of a table by having separate metadata, okay, that tracks which files are part of the table, stats on those files, what the table schema is, how the table is partitioned. And using all this metadata, we can now identify how the table looks like, but then also identify whether we need to even open a file in the first place. So instead of me having to list every file in the folder, I have an already baked list with the stats I can use to determine whether a file needs to be scanned or not, allowing me to scan that table much, much, much more efficiently. Okay, and then you get the benefits. Now, basically, you have tables that you can discover very much like a traditional database table. This enabled faster scans. It also allowed this metadata to track different versions of the table, so you could do time travel. It allowed there to be mechanisms like optimistic concurrency control to enable ACID transactions, so you can have those same guarantees. You can do, if you need to update one row, you can do it fairly efficiently compared to how it used to be. If you need to update the schema, you can without having to rewrite the whole table. You can, with Iceberg, you can actually even change the way the table partitions without having to rewrite the whole table, which is pretty nice. So when you take a look at the structure of a format like specifically Iceberg, because again, Iceberg became the industry standard and Dremio was one of the first to really embrace Iceberg, okay? You're talking about 3, 4, 5 years ago, Dremio was kind of really beating the drum for Iceberg before most companies were even in the early stages of even considering Iceberg as part of their product. But the way it works is that generally there's going to be a catalog, something like an Apache Polaris, which I'll discuss later, that then it acts as like a traffic controller pointing you to where the metadata for the table is. That metadata file, the JSON file, tells you the schema, the partitioning of the table, and where you can find its snapshots. That'll point us to the snapshot we're trying to scan, which is a list of groups of files called manifests. So a manifest list is a list of manifests. And each manifest represents a group of files that make up the table. And I can take a look at the stats for those manifests within the manifest list to determine whether a manifest needs to be looked at all, Okay, usually you're doing that based on partitioning. So you're doing partition pruning at the manifest list level. And then when you get to the individual manifest, you can take a look at the stats for the individual files and do min-max filtering, where you can determine whether the range of values in a particular file are relevant to your query and skip the file if it isn't. So by the end of the time you go through all this metadata, you might have a table that's 100,000 Parquet files, but really only end up having to scan like 100, depending on how specific your query is. And that's all possible because of the Iceberg metadata that allows you to build that list of files that you're going to go scan in your data storage. But at the end of the day, we're going to have all these Iceberg tables. Someone has to know which Iceberg tables exist and who has the ability to access them. And that's the role of the catalog. And that's what Apache Polaris is, which Dremio is a co-creator of. It is a co-creator of this Polaris catalog, along with Snowflake, which allows you to access the listing of all your Iceberg tables, discover where their metadata is, but also to control who can access those tables. And within Apache Polaris, basically you're able to kind of manage different catalogs within your Polaris instance. And each catalog can have its own namespaces. Think of them as like folders, and then tables within those, and views within those namespaces. And you're able to manage role-based access controls among those different catalogs, among your different users, referred to as principals. So principals are your users, and think of catalogs as like different bundles of tables. Okay, and then, so I might have all my sales related tables bundled in a sales catalog, all my customer related tables bundled in a customer catalog, all my logistics related tables in a logistics catalog. Now within Polaris, what I can do is I define principal roles. So these are roles that will help different users discover what access they have. Okay, so in this case, we have an analyst, an engineer, and a shipping partner role. So we'll assign those to the respective principals. But right now, those principal roles have access to nothing. To give them access to something, I gotta first create a catalog role. And a catalog role is basically determines, hey, is basically a bundle of privileges towards a specific catalog. So basically, sales reader is going to have the privileges necessary to read the tables in the sales catalog. Sales writer, the privileges to write to the sales catalog, and so forth and so forth. So then what I can do is I can assign those catalog roles to principal roles like analyst. I'm going to give them just the reader roles because I just want them to read. An engineer, I'm going to assign them all the roles because they need to be able to read and write to all the catalogs. And a shipping partner, they're only going to need access to our logistics information. So I'm only going to assign the logistics reader catalog role to the shipping partner principal role. And there I've kind of assigned them, they all have the right level of access to what those need. And again, you can get really granular with how you design those catalog roles. You basically assign to them very specific privileges about what they can do with individual tables, what they can do with individual views in the catalog, and individual namespaces in the catalog. You also have the ability to kind of give them just more broad permissions at the catalog level and say, hey, they can read and write all the catalog stuff. You can get really granular with the privileges that will exist within one of these catalog roles. So that way you can build the taxonomy of access control that you need. And the idea is that by building it out in catalog and principal roles, it makes it more easier once you build it out to be able to reuse your principal and catalog roles. So you're not having to really create a tailored access control for each individual user. So when we throw in Dremio into the mix, the world as it begins to look like is you have Iceberg tables, because that's how you're going to store your data in your data lakehouse. Those tables are going to be tracked by different Iceberg catalogs, and Polaris can actually not only know about the tables within its own catalog, but Polaris has the ability to federate or connect to external catalogs. So this could be like Nessie, Gravitino, Unity, or other Polaris catalogs. And so that way you can see all your tables from sort of one single Iceberg catalog. Okay, and then again, Apache Polaris providing governance on the tables it's managing and allowing you to federate to other catalogs. But that's not all your data. Again, you're going to have data in databases, data lakes, and data warehouses. This is where Dremio comes in and being sort of the unifier of all your data. Okay, bringing its own governed semantic layer and query federation into play. So that way, all your data is accessible in one place. Again, open on data going in and open on data going out. using open interfaces like Apache Arrow Flight that allows you to bring that data into any platform that you want, whether, again, Arrow Flight, JDBC, ODBC, REST, MCP. You have lots of different options on how to interact with the platform. So all that data, again, it becomes accessible for things like AI workloads, BI workloads, etc. So again, these are some of the primitives that are really become the cornerstone of the modern data lakehouse world. This is Apache Arrow, Apache Iceberg, Apache Polaris. And Dremio has been at the forefront of basically making all these things exist. Well, basically, again, by being part of the early stages of Apache Arrow, by being one of the biggest people to early on to embrace Iceberg and really build it as part of its product and really evangelize it, and being a co-creator of Apache Polaris, Dremio has always had a commitment to open primitives and building a platform that builds around these open primitives. So hopefully you guys enjoy this. Scan the QR code, go get yourself some free books. I'll see you all in the next one. Have a great day and enjoy.